Today we are going to cover amines. Amines are important organic derivatives of ammonia. Ammonia, as you know, is having structure N with three hydrogens, and nitrogen has one lone pair of electrons on it. If I want to derive amines from ammonia, I'll write the name first. This is ammonia. And if I want to derive amine from this ammonia, I can replace one of the hydrogen here. So I'll write instead of HR N and remaining hydrogens will be as it is with the lone pair on the nitrogen intact. So R here represent an alkyl group, and the general formula of this particular compound can be written as RNH2. If I replace the remaining hydrogen, first I'll try to replace this particular hydrogen with alkyl group RNRH with the remaining lone pair on the nitrogen. And if we try to remove another hydrogen, then it will be R, N, R, and R with the intact lone pair on the nitrogen. So here is the basic idea of amines, that they are derivative of ammonia, which is NH3. We are trying to remove the hydrogen here and trying to replace it by R. Now it is RNH2. Then the remaining hydrogens are replaced to give us this particular structure, and the third hydrogen is replaced to give this particular structure. Amines are basically classified as primary, secondary, and tertiary amine according to the number of alkyl groups attached. For example, in this scenario which we have discussed, we have one alkyl group present. So if one R group is attached to the nitrogen, it is called as primary amine. If you have got two R groups attached to that particular nitrogen, it is called as secondary amine. And likewise, if all the hydrogens are replaced by 3R, that is 3 alkyl groups, it is represented as tertiary amines. So the general formula, as we have discussed, varies. Here, the general formula for primary is this one, RNH2. The general formula for secondary is two R's attached to nitrogen with one hydrogen. And finally, we have got a tertiary hydrogen where all the hydrogens are replaced by a single 3 R's. Next thing, an important part is basicity of amines. We have discussed previously acidity of carboxylic acid. In the similar way, we are going to discuss the basicity of amines. As we said in acid topic, that an acid is a good acid if it is trying to donate proton. Proton is H plus. Here, contrary to it or the opposite of it, is a base is a good base if it has good tendency to accept protons. So in that case, if I am going to discuss about amines, I'm just writing here RNH2, primary amine, with the lone pair on the nitrogen. And as I said, a base can be termed as a good base if it has the tendency to accept proton. And if it is going to accept proton, these lone pairs which we are trying to denote on nitrogen will help in the formation of a bond. So the incoming proton is going to attach to the nitrogen with the help of this lone pairs, and it will form a bond, and that will give us RNH3. As the nitrogen is losing the lone pair, nitrogen is going to get a positive charge. So the basic thing what you have to remember here is amines are basic in nature, and who is helping them to show that basic character are the lone pair of electron which are present on the nitrogen. So this lone pair of electron which are present is actually helping in the formation of new bond with the incoming proton. So if we are trying to generalize the reaction here, we can write down R and H2 with the lone pair representation on nitrogen is going to react with HCl. Here the hydrogen will be transferred to the nitrogen in the form of a proton, and the lone pair is actually helping in the formation of a bond. So we are going to get this particular structure here, that is R. I'm just writing here H, H2, Cl minus. Because nitrogen is losing the lone pair, it will get positive charge. And the Cl minus here is due to the transfer of sigma bond to chlorine, and chloride ion, chlorine is more electronegative. That is why it will pull the sigma bond or sigma electrons towards it to get this negative charge. The simple representation can also be in this way, where we are writing RNH3 with a positive charge on nitrogen and Cl minus. This particular compound is called as R is alkyl group, NH3 is ammonium, Cl is chloride. It is alkyl ammonium chloride and it is in a form of a salt. The salt is formed when a base and an acid reacts. So this particular compound, which is alkyl ammonium chloride, is a representation of a salt. Now, as we have discussed in acid also, the strength of an acid is determined with the help of acid constant, which was Ka. Similarly, a strength of a base can be calibrated or evaluated with the help of a constant by name basicity constant. This basicity constant can also be termed as base dissociation constant. As we have discussed similarly on the same lines in acid, a strong acid will be ionized completely. Similarly, a strong base will also ionize completely in aqueous solution. But amines are weaker bases. Amines are supposed to be weaker bases. So a weak acid will ionize partially in the same way. A weak base will also ionize partially. An example for this can be RNH2 in aqueous solution, means it is happening in the presence of water, that is H2O. One of the hydrogen will be transferred here in the form of proton, so that we get here RNH3. As you know that we'll get a positive charge on nitrogen because the lone pairs are utilized in the formation of a new bond, plus we have got here is OH minus. So if this is actually reversible reaction, so the extent of ionization can be described with the help of a constant by name Kb, that is base constant, which is actually given by a formula where the concentration of the product side, that is in the ionized form. So I'm writing whatever we got in our product side, that is R NH3 plus and OH minus divided by unionized form, that is R NH2. If I don't write water also, it won't be making any change because the concentration of water product value will be equal to 1. So if we can omit this also, it will be easier for remembering. So the definition goes by that the concentration of the product of ionization in moles per liter, it is in the form of moles per liter, divided by concentration of unionized base. This is your unionized base. So Kb value will actually help us in evaluating whether the given base is strong or weak. If you have got higher Kb value, that means it is a stronger base. If you have got lower Kb value, it is supposed to be a weaker base. Right. Their basic uh, debate will be which is more basic, ammonia is more basic or your amines are more basic. For that understanding, we need to know here that if you try to represent ammonia here, you have got N right here. This is your ammonia, this is your lone pair on ammonia. Amines will be represented in this way with the lone pair. The basic difference between amines and ammonia is amines are having R group and ammonia will have all sides will be hydrogens. In the final inductive effect, we have seen one concept that alkyl groups, which is R here, are electron releasing or electron donating groups. Because electrons are given more by R or alkyl groups, the concentration of electrons will be more. So when you compare ammonia and amines, amines are supposed to be a stronger base and that will be represented in the form of Kb value will be more if you compare for amines and ammonia. And in the notes itself, I have given a statement where amines are more basic than ammonia because the electron releasing or electron donating groups, that is alkyl group, increases the lone pair availability. So it is giving electrons towards the nitrogen. So the availability of lone pairs of electron will be more. The basic term we need to remember is availability of lone pairs of electron is more due to electron donating R group in amines compared to ammonia. The next important topic is relative basicity of amine. I mean to say out of ammonia, primary amine, secondary amine and tertiary amine, which is supposed to be more basic in nature. So in relative basicity, we are trying to compare the values or the basic strength of amines. First thing is, amines are more basic than ammonia as we have discussed before because of this electron donating R group. Next important thing here is why it is making it more basic because they are increasing the electron density around the nitrogen. That is also we have discussed, thereby increasing the availability of lone pair of electron. The same statement we are trying to make in relative basicity of amine. Now the values we are just trying to calibrate here for ammonia, that is NH3, the Kb value is supposed to be 1.8 into 10 to the power of minus 5. The next compound, that is primary amine, that is CH3NH2, that is methyl amine, the Kb value is equal to 37 into 10 to the power of minus 5. That means 1.8 was the value for ammonia, but for primary amine, that is methylamine, is 37 into 10 to the power of minus 5. So the value itself suggests that this is more basic than ammonia. Next compound is dimethylamine, that is CH3NHCH3. The Kb value for this compound is 54 into 10 to the power of minus 5. So this is more basic, followed by the compound that is CH3NCH3CH3. All the hydrogen are replaced by alkyl group. This particular compound is called as trimethylamine, but the value here is Kb is equal to, it should be actually more than 54, but the value is 6.7 into 10 to the power of minus 5. So why is the value less for this trimethylamine? As we are seeing the trend here, ammonia was 1.8 followed by primary amine which was 37 into 10 to the power of minus 5. Secondary amine was 54 into 10 to the power minus 5. So on this regard, it should be more than 54, that it means it can be 70 or 80, but actually it is 6.7 into 10 to the power of minus 5. The basic thing here I'm just trying to represent here, the why is this uh, the values are different for this tertiary amine is because of this concept. That is, if you have got this amines here and a lone pair represented here, as you know that more electron donating group, more is the availability of lone pair of electrons on nitrogen. But what happens here is, to show the basic property, the incoming proton should come and attack to the particular lone pair. But due to this bulky group in the sense this all methyls, 3-methyl group, it will try to interrupt the transfer of proton. And this interruption of transfer of proton due to the bulky group on nitrogen is called as steric hindrance. It is called as steric hindrance. That means it is blocking the path. So the basic analogy, what you have to remember, electrons are present in bulk number or in good numbers, but the path is blocked. That is why it is not able to show its basic city property. That is why it is not enabling the formation of bond with the incoming proton. So that is why the value is 6.7 into 10 to the power minus 5 instead of more than 54. So that is what is the basic thing what you have to remember in this basicity of amines. Very simple topic. It is very easy if you know the concepts which we have already studied in your intermediate levels. So we have started with the amines topic that they are derivative of ammonia. We have seen primary amine structure, secondary amine, tertiary amine. In primary amine, you have one alkyl group present. In secondary amine, you have got two alkyl group present. In tertiary amine, you have got three alkyl group presents, which is represented here. Next, what we have seen is the reaction where a base reacts with an acid to form a salt where we are getting alkyl ammonium chloride. Then we are trying to study the basicity constant and which is governed by this particular reaction where a weak base reacts with water to give RNH3 plus OH minus, and the Kb value is represented in moles per liter here. Kb value is actually helping us in deciding whether a base is stronger or weaker base. And here we are just trying to see how ammonia is less basic than primary amines is because of electron donating R group, which is increasing the electron density on the nitrogen, thereby increasing the basicity. We have seen the values are also, there is some disturbance in the value for tertiary amine due to a property called steric hindrance. That is why it is having lesser Kb value, that is 6.7 into 10 to the power minus 5. The anticipated value is actually supposed to be more than 54, but it shows 6.7 due to the steric hindrance. That is what is the essence of the topic which we are going to cover today. The next topic will be the qualitative test for amines along with the structures. This will end this fifth chapter, and I'll try to send you the important question from this chapter by today evening. Thank you.